Yes, sir.
I saw this before in test before.
Okay, it would have been an accident because we did not learn this year. I know that for a fact. They took that standard out and gave it to 7th grade. So this is the first year you guys will not have to do this on the SOL. And it's also the first year you get to use Desmos. Guys, they're trying to make this test so great for you guys. What's up?
Yeah.
Oh, you have? Okay. Well, that was all by mistake. But we got to keep moving, guys.
I saw them.
I'm sure. All right, but I'm letting you know the SOL will not have it. I was made very clear of that. All right, so which of these is integer? Integers. I'm going to actually write a little note here. Integers equals plus and negative whole numbers. No, that's helpful. I like it. Whole numbers and 0. All right, so positive and negative whole numbers and 0 is what integers are. All right, that's what integers are. Okay, so now we look through. 7/10? Nope. All right, 6.5, not a whole number. Negative 12 is a negative whole number, so there you go. This one, not a whole number, it's a mixed number. So it can only be C. And as long as you know what integers are, these kind of questions are going to be easy. But they know that a lot of you guys forget about integers when it's time to take the test. And so I want to make sure that you guys understand it. Because these should be easy questions, but you'd be surprised how many people get them wrong. Probably about 60-70% of people get these wrong. All right, moving on. Here we go. So which ratio, comparing two numbers, ratio, correctly represents 0.1%? 0.1%. So I'm going to turn that into a decimal. I'm going to tell you that right now because I need to work it to a fraction, but it's a lot harder to make it a fraction when it's a percent decimal. I mean, it's a percent and a decimal. They threw everything into one. So 2 places away from your percent sign. Get away from it. All right. So 0.001. So 0.001, and we need to figure out where that is. This is the tenths. This is the hundredths. And lastly, this is the thousandths. So 1 thousandths, 1 over 1,000, 1 over 1,000. All right, there it is, D. So that's how that works. Turn it into a decimal, and then you'll know exactly your place values. As a percent, we don't really know where the place values belong when it turns into a fraction, unless you just have a big percent, like 20% or 1%. Then you know it's 1 out of 100 or 20 out of 100. But here, you got to turn it in. When it's a decimal percent, those are a pain. All right, turning over. We are getting there. All right, which of these lists the numbers in order from least to greatest? All right, like so far, even though this is a calculator section, a lot of these questions have been non-calculator helpful. So just keep that in mind. You don't always need to use your calculator just because you can. All right, least to greatest means going up. Starting from the bottom, now you're here. All right, so least is going to be the most negative. If you have a number line, negative on this side, positive on that side, if you need to just jot a couple spots to figure it out, say, 3, 16, negative 16, and 47. Those are the 3 numbers they give us in a bunch of different orders. So I know negative 16 is the only negative, so I'll put it on the left. All right, then I know 3 is going to be a positive. There you go. And then 47 is going to be a big positive. So it needs to be in this order from least to greatest. So which one has negative 16 first? This one does, and that one does. Which one has 3 second? Only B. So it has to be B. All right, if you need to make yourself a little makeshift number line, don't be afraid to do so. It's only 3 numbers. All right, moving on. So identify each statement that's true. So what is true here? Once again, you can make a number line, and that'll help you out sometimes. All right, so negative 5 is greater than negative 8. Negative 5 would be to the right of negative 8. So negative 5 is greater. All right, circle. That's good. Negative 1 is less than or equal to negative 6. Well, it's not equal to, but let's see if it's less than. Negative 1 is less than negative 6. Well, negative 1 would be like right here. Negative 6 would be right here. Well, no, negative 1 is more. It's to the right. It's on the positive side, or more positive. So therefore, that's not true. All right, negative 7 is greater than or equal to negative 4. We know it's not equal to, but let's see if it's greater than. Negative 7 is greater than negative 4. Well, negative 7 would go like right here. And negative 4 would go right here. All right, well, nope, negative 7 is less than negative 4. It's more to the left, so that's not true. All right, 3 is greater than negative 9. I don't even need to put that on a number line. Every positive is always going to be greater than any negative, and this is saying a positive is less than, so that's not true. All right, negative 3 is greater than 2. No negative is greater than any positive. Not true. 10 is greater than or equal to 8. It's not equal to, but it definitely is greater than 8. So these are the only two correct answers on this one. The top left, the bottom right. All right. Oh, no. We got pizzas. We got pizzas. And you may very well see this on the simulation test. All right. So this picture represents 4 whole pizzas, and they're split up into fifths. 1, 2, 3, 4, 5. Fifths. They're split into 1/5. How many 2/5 are there in 4? So let's find out. All you got to do is circle groups of 2, because you're looking for the numerator. When you see this, you're dividing by the numerator, basically. This is the same as saying 4 divided by 2/5. If you want to do it mathematically, you can, and you'll still get the right answer. But I'm letting you know how we work these visually. It says how many 2/5 are in 4. Well, they're already in fifths, so now we see how many groups of 2. 1 group of 2, 2 groups of 2, 3 groups of 2, 4, 5, 6, 7, 8, 9, 10. So it should equal 10. I'm going to go ahead and circle that because I know that's going to be the right answer. But let me show you mathematically too. 4 over 1 divided by 2/5, KFC. All right, because you have 4 wholes and you're dividing them in 2/5. Okay, so 4 over 1 times 5 over 2 equals 4 times 5 is 20. 1 times 2 is 2. 2 goes into 20 10 times. So there we go. Mathematically, visually, we got both. I'll leave it up there for a second for anybody that wants the mathematical version too. All right, and another thing is, so 2/5 here, 2/5. I'm doing this in the Desmos calculator. Those watching the video, you won't be able to see it, but I'm putting 2/5 into my Desmos calculator, and it tells me 0.4. So I can say 4 divided by 0.4 equals 10. So it tells me the answer. So that's another way to do it. This is a calculator question. Therefore, if you want to use your Desmos, use it. It looks weird having 4 divided by 0.4. It works great. All right. Moving on. Valerie wrote the values of the powers of 3 that she knew. So 3 to the first power is 3, 3 to the second power is 9, and so forth. So what is the value of 3 to the 5th power? Well, that's a Desmos question. 3 to the power of, so AB button, A to the B button, and then 5, right? There we go, equals 243. The end. Back in the day, they had to use this calculator to do it. The other calculator still does work these. Anything over to the 3rd power, they're going to go ahead and make sure you have a calculator for. So just know that. Nothing past 2 to the 3rd power. Not 3 to the 3rd power. 2 to the 3rd power is the biggest 3rd power they give you. But squared, they'll give you anything squared. They'll give you 20 squared. You know, they'll go up with that. All right. But that's all you got to do. I'm not even going to show a different way just because that's how I hope you guys do it. All right. Now we got a word problem. Let's break it apart. Samuel bought 4 rolls of tape to seal boxes. 4 rolls of tape. All right, each roll contains 32.9 meters of tape. Each roll. All right, he uses 1.2 meters of tape to seal each box. What is the total number of boxes he can seal with 4 rolls? All right, total number of boxes he can seal. So we say he has 4 rolls. 4 rolls. All right, 32.9 meters per roll. I'm just breaking out the information so I make sure that I understand it. Let me turn this away so you can see that better. All right. And then we also have 1.2 meters to seal. 1.2 meters to seal. All right, so how many can he do? Well, if you have 4 rolls at this much, we can find out how much meters in all by multiplying these two. All right, so let's find out. 4 times 32.9. Definitely going to do that in the calculator. 32.9 times 4 equals 131.6. So 131.6 meters in all is how much he has in tape. It was just 4 times how much each roll has. All right, now we can just divide that by 1.2 to figure it out. So over 1.2. Let's put that in the calculator. So you could always type in A and S to get your last answer, or you can retype it in there. Divided by 1.2. All right, so 109.6666666. All right, so he can do 109 boxes. He can't do 110 because it didn't say 110 point something. It said 109 point something. So he can do 109. Just to let you know, sometimes they do put 110 as an option on here. They didn't on this one, but I have seen it before. Just be careful. All right. And I'll leave that for a second just to make sure everybody's got it. All right. Y'all are doing great. Let's keep this going. Mia's working on projects that require 3.5 yards ribbon per project. All right, ribbon per project. Okay, Mia has 28 yards. 28 in all. All right, what is the greatest number of projects she can complete? So if you have 28, if you see a big number and a little number like this and you're trying to figure out how many times it goes in there, I mean, that's division. This is division. This is 28 divided by 3.5. Now, yes, you could do that by hand. I'm not going to. All right, so 28 divided by 3.5. If you don't know 3.5 is 3.5, type in 1 divided by 2 in your calculator. It'll give you 0.5, and then just make sure it's 3.5 when you're dividing it. All right, that gives us 8. Our answer is 8. Students did not have this ability in 2014, and you're still going to get these same questions. So you're getting the same easy, the same hard back then question, but now it's easy. Type it in the calculator. All right, you got a super calculator. Use it. All right, moving on.